So, in my previous video when I was explaining expressions, I wrote this tiny program that takes two numbers and compares them with operators, and then it dumps all these messages to the console explaining whether if one number is greater than the other, smaller than the other, equal, etc., etc. Which is great, but perhaps it's a little too much information. And what I want to do is I want to write a program that just gives me the one message that tells me how those two numbers compare, if one is greater or smaller or whatever they look like, right? This is going to be a good example for me to describe a new technique that we're going to learn with this video, which is making programs execute code only under certain conditions, only if certain criteria meets. So for example, let's say that I have this new program where I have two values, right? And then right now A is greater than B. So if I print this to the console, then I will get a message that is correct. 10 is actually greater than 5. But if I were to change this, or if during the life of the program it changed, then now the console is printing a message that is wrong. 3 is not greater than 5. So what I would like to do is I would like to either print this to the console only if A is actually greater than B, or print a different message if they just happen to not be greater than the other one. The way we're going to do this is with a new structure that we're going to learn, which is called if statements. All right? And if statements is just a way of writing code in a way that we define that a particular block of code should only be executed if a particular condition meets a particular criteria. So how is that going to work? Well, what I'm going to do is, first of all, I'm going to wrap the lines of code that I want to only execute under a certain condition with curly brackets. So I'm going to do this, and I'm going to move this here, and then in front of this block of code, I'm going to add the word if, and then I'm going to open and close parentheses. And inside of this parenthesis, I'm going to write an expression that needs to evaluate to true or false, describing what criteria needs to meet for this line of code, for whatever is inside of this block to execute. So in this case, because I want to print this only if A is greater than B, then as we saw in the previous video, I can just type A greater than B, and whenever this computes, if this equals true, then all the code inside of this block will execute. Otherwise, the computer will just keep going, right? So for example, if this was 10 and I execute it, you can see that this line of code executes. But if I were to change this back to the number 3, you will see that I will get no output in the console. Because since this was not since this was not true, then the computer totally skipped this block of code. All right? Does that make sense? So this is a super simple. Anything that you write in here needs to be able to be crunched into something that evaluates to true or false. All right? So now we have a program that is a little bit smarter, so it can decide whether if to print or not this message, but I want to make it a little better. So I want to make it so that it can also print whether if A is smaller than B, right? So something that I could do very easily is I could just copy paste this and say, well, if A is greater than B, print this. But if A is less than B, then just print A is smaller than B. Okay? Which means that now A3 is smaller than 5. And if I were to change this, now what I get is 10 is greater than 5. Correct? All right. Wonderful. So my program is now much better because now I can print one condition or the other condition. All right. So it skips this block of code or it keeps this other block of code here. Right? However, if structures can be made smarter by chunking together, combining together, concatenating together series of instructions and series of conditions. What do I mean by this? In this particular case, because we're comparing two numbers, right? Whether if one is greater than the other, we know that if this is going to be true, because of the nature of the comparison we're doing, greater or smaller, we also know that this will be false. because just mathematically those two things cannot be true at the same time. So we know that these two conditions are mutually exclusive. However, right now, the way we have written this program, both conditions are checking. The computer is checking if A is greater than B and then executing this. And even if this went through and it printed to the console, the computer is also going to check for this condition. So in a way, we're wasting a little bit of computer resources because we know that if this was true, there is no necessity to check this anymore, right? So even though comparisons of this kind are extremely cheap for a computer to do, from a computer programming perspective, it's much more elegant to just join the two conditions into one single if statement that executes one thing or the other. And the way we can do that is that we can concatenate these two conditions by saying, if A is greater than B, do this. Otherwise, else if, and then I can print here the other conditions, else if A is greater than small, then print this other one here. So what I'm doing here is that I'm saying, if this were true, run this and then finish the if conditional. Otherwise, if this was false, then try to check if this was true and then print this other way here. So it's going to be either one of the other. If this was true, the computer will stop checking here. If this was false, then the computer will continue checking any other of the conditions that can go after that. So is this going to work? It is going to work. 10 is greater than 5 and 3 is smaller than B. Okay? And I could copy paste as many of these as I wanted. You can add an if statement must start with a simple if, all right? But then it can have as many else if ifs as you want. In this case, it doesn't really make much sense what we have here, but you could concatenate as many as you want. Now, are you already thinking of what I'm going with this next? Which one of the conditions of the possibilities we have not yet accounted for in this comparison program? We have not accounted for the fact that these two numbers might be equal. Okay, so if they are equal, you can see that none of the two conditions actually meet. And if they don't meet, then I'm printing no message to the console. So my program has a tiny corner case. We usually refer to this like very very strange, very rare conditions that sometimes only meet. You know, it has a small corner case that we haven't really accounted for. So how could we print another message saying that A is equal to B? Well, as I said before, we could say, well, else if A is equal to B, then A is equal to B. Remember that when we want to compare if two things are the same, we use two equal symbols. All right, one equal symbol is assignment. Two equal symbols is comparison. This is a really common confusion and something that we forget very often when we start programming. Okay, so we could add this, and this program will work perfectly because now we will actually get this done. 5 is equal to 5. Okay. The only thing that I'm going to show you is the fact that in our particular example, in this one example where comparing two numbers only has 3 possible outcomes, one is greater than the other, one is smaller, or they're equal. Because if this is false, and if this is also false, due to the nature of this comparison, it follows arithmetically that they have to be equal. They must be equal. Therefore, this check is redundant because I know that if the computer got to this point, is because the only option that is left is that the two numbers must be equal. Therefore, I can actually save myself this check by removing everything and then just finishing an if structure with the last clause, which is going to be else, and then printing this here. What this means is that when you finish an if structure with the word else, it means if anything that you have checked before was false, then the last resource, just execute this code. So if the computer got to this point, then no matter what happened before and no matter any other checks, this code is going to be executed. All right? So this is the way how you write if statements. You always have to start with a simple if. Then in the middle, optionally, you can have as many else if, else ifs as you want, but they're optional. And also optionally, you can end the if statement with a generic else. If everything before this failed, then execute this piece of code here. But this is also optional, okay? And this is how you make decisions. This is really, really the bread and butter of computer programming. If statements and an expression that evaluates to true or to false. Through the course of this series, we're going to see probably like 1 million examples of applications of this. Okay, so stay tuned for that.